Hi everyone, here is the lesson video for Math Module 5, Lesson 31. So this lesson is all about adding fractions together, specifically adding mixed numbers. So let's start off on slide 2, looking at problem number 1. It's just telling us to solve. So what they're going to do is they're going to start off by breaking apart that fraction, that mixed number, into a whole number and a fraction. And same with our second mixed number. So again, they're going to break it up into a whole number and a fraction. Then what they did is they took those whole numbers, so 3 and 2, they added it together to get 5, and then they added the fractions together, so 1/3 plus 2/3 to get 3/3. So that's basically what we're going to be doing on this lesson is we're going to add the whole numbers together, then add the fractions together, and then finally put them all together at the end. So a lot of you guys might recognize that 3/3 is also equal to 1 whole, because remember, whenever a fraction has the same numerator and denominator, it is equal to 1 whole. So this one is really like saying 5 plus 1. And I hope we all recognize that 5 plus 1 is equal to 6. So that is going to be our final answer. And again, I forgot that I am on the teacher side, so I cannot type in my answers. I will be writing my answers. Just make sure that you guys are typing in your answers. So let's keep on going. We're going to look at part B. Part B, we have 4 1/4 plus 3 2/4. So I'm going to start off by just adding my whole numbers together. So I'm going to start off by doing 4 plus 3. Well, I know that 4 plus 3 is equal to 7. And now up here, just so it's different spaces, I'm going to add my fractions together. So I have 1/4 plus 2/4, and they both have the same denominator, so I don't have to worry about changing them. Remember, if two fractions have the same exact denominator, you keep the denominators the same and you just add the numerators together. So we're going to add 1 plus 2, and that equals 3. Now that I added my whole numbers together and I added my fractions together, I can go ahead and just slap those two together and get my answer of 7 3/4. This is a little bit different than part A because this time our added fraction did not equal a whole number. It was just a fraction, so that's why we're leaving the fraction the way it is. And that's pretty much all we're doing on this assignment. So part C, we have 2 2/6 plus 6 4/6. So I'm going to go ahead and start off by adding my whole numbers together. So I am going to do 2 plus 6. Well, I know that 2 plus 6 is equal to 8. And I don't have a whole lot of space up above, so I'm going to kind of move it over here. So now I'm going to add my fractions together. So I'm going to add 2/6 plus 4/6. And again, they have the same denominator. So whenever two fractions have the same denominator, we just keep the denominator the same and add the numerators together. So now I can just add 2 plus 4. 2 plus 4 is equal to 6. But oh, look here. Yet again, our numerator matches our denominator. They are the exact same number. So that means whenever the numerator matches the denominator, that means that that fraction is equal to 1 whole. So now I have 8 wholes plus 1 whole. So in order to get my answer, I'm going to add those two together. 8 plus 1 is equal to 9. So now the only thing that you guys really have to look out for on this assignment is whether or not, once you're done adding, your fraction equals 1 whole. Because that's the only thing that you'll have to pay attention to. If you write 8 6/6, I will not accept that because 6/6 should be written as 1 whole. You would not ever go to a pizza place and say, I would like 8 6/6 of a pizza. They would look at you like you are talking in gibberish. You would say, I want 9 pizzas. So that's the only thing that you really have to pay attention to. Now for number 2, it is telling us again to solve and use a number line to show your work. You can definitely use a number line to show your work if you would like to, but you do not have to. I will show you as an example for number 2, part A, but from then on, I'm just going to add the fractions together. So let's look at number 2, part A. We have 2 and 4/5 plus 1 and 2/5. So they already started out by adding the whole numbers together. So 2 plus 1 equals 3. And then they added the fractions together. 4/5 plus 2/5 is equal to 6/5. This time around, that is an improper fraction. It is not equal to 1 whole, so we have to figure out what it actually equals. So they broke it up here on a number bond for us. So they broke it up into 5/5 or 1 whole and 1/5. That is another way to write 3/5. So if we want to figure out what our actual answer is and we would like to use the number line, I would start off by plotting a dot at where our whole number is. So our whole number is at 3, so that means that I would put my dot right at 3. And now you could do this one of two ways. If you did not want to do a number bond, you could just count up by your fraction, which is 6/5. So that would mean you would do 1, 2, 3, 4, 5, 6, and land right there. Or, and I'm going to change my color here just to differentiate it, you could do count up by the number bonds that they separated this into. So you could go, well, hey, 5/5 is 1 whole, so I could just jump from 3 to 4. And then I have 1 extra fifth, so I'm just going to jump from 4 to that 1 extra fifth. Either way, you guys will end up with the same answer, and you will end up at 4 and 1/5. And again, you guys do not have to do the number line. It is only a tool to use if it helps you. So like I said, I'm going to show the number line for this example, but moving forward, I'm just going to plain old add the fractions together. So let's move on to part B. Part B, we have 1 3/4 plus 3 3/4. And I'm going to use this space over here to rewrite everything because there's just not enough space otherwise. That was a very poorly drawn rectangle. Let me try that again. So again, I'm going to rewrite things over here so that I actually have space to solve my problem. So I'm going to start off by adding these whole numbers together. So I have 1 plus 3. Well, I know that 1 plus 3 is equal to 4. So I added the whole numbers from my mixed numbers, but now I still have to add the fractions. So I have 3/4 plus 3/4. So yet again, the numerator and denominator are the denominators are the same. So when we add them together, we just keep the denominator the same. We don't mess with it. And now we just add our numerators together. So we have 3 plus 3. Well, I know that 3 plus 3 is equal to 6. And this is one of those problems where we have to do a little bit extra work because we ended up with 6/4, which is an improper fraction. We cannot just say, oh, our answer is 4 6/4. Because again, if you go to a pizza place and you try to order a pizza and say, I would like 4 6/4 pizza, they're going to look at you like you are talking gibberish. So before we can write our final answer, we need to change that improper fraction to a mixed number. So remember, we do this by figuring out how many times does 4 go into 6. Well, I know that 4 goes into 6 one time. I can't keep going because I'd be going past 6. And I know that I keep my denominator the same, so I'm going to go ahead and write that. So 4 goes into 6 one time. That 4 is 4. And then I just have to figure out the difference between 4 and our old numerator of 6. So you can either count up from 4 to get to 6, or you could do 6 minus 4. Either way, you're left with 2. And now, after converting it to a mixed number, we are still not done yet, because we cannot forget about that whole number that we started out with. So now the very last thing that we have to do before we're all done with this problem is add that whole number back in. So I'm just going to write it out down here. And I'm just going to write it below the whole number because we don't have to do anything to that fraction. We are just adding these whole numbers together. So 1 plus 4 is equal to 5. And like I said, we're just keeping that fraction as is. So 5 2/4. And now we finally ended up with our actual answer. And again, you guys will just need to make sure that you type in your answer. Okay, let's keep on going. So part C, we have 3 and 3/8 plus 2 and 6/8. So again, I'm going to start off by adding the whole numbers together. So I am going to do 3 plus 2. And I know that 3 plus 2 is equal to 5. So I added my whole numbers together. I'm just going to leave them hanging out there for just a second so I can focus on the fractions. So I have 3/8 plus 6/8. So right over here, I'm going to go ahead and add those two fractions together. 3/8 plus 6/8. Again, they have the same exact denominator, so whenever that happens, I can just leave the denominator alone and just add those two numerators together. So in that case, I have 3 plus 6. Well, I know that 3 plus 6 is equal to 9. And again, we end up with an improper fraction where the numerator is larger than the denominator. So this means that before I can figure out my final answer, I have to change this improper fraction to a mixed number. So remember, we change an improper fraction to a mixed number. Excuse me. By figuring out how many times our denominator can go into our numerator. So I know that 8 can go into 9 one time. Can't go in anymore because if I kept going, I would go past 9. And I know that I'm keeping my denominator the same. I'm not messing with it. So now I just have to figure out my new numerator. Well, like I just said, 8 goes into 9 one time. 1/8 is 8. So I can either stay at 8 and count up to 9, our old numerator, or take our old numerator and subtract 8 from it. Either way, I get 1, and I get the fraction, the mixed number of 1 and 1/8. However, I am not done with this problem yet because remember, the first thing we did was add those whole numbers together, and I cannot forget about that whole number. So the very last thing that I have to do is take that whole number and add it to our mixed number. So again, we don't have any fractions to add in this example, so the fraction stays the same, we don't mess with it, and we just add our whole numbers together. 1 plus 5, well, I know that 1 plus 5 is equal to 6, and now we get our final answer of 6 and 1/8. And let's keep on going. So slide 3, we're just going to keep on doing the same thing. We're just going to solve using whatever method works for us. So let's look at number 3, part A. We have 2 and 4/6 plus 1 and 5/6. So they started out by adding the whole numbers together, which is where they get that 3 from. And then we still have to add the fractions of 4/6 plus 5/6. They're doing it a little bit differently with this number bond here. I'm just going to cross that off, and I'm just going to keep going the way that we have been going. So we have our whole number of 3. We're just going to leave it there for a second. And over here, I'm going to go ahead and add those two fractions together. So we have 4/6 plus 5/6. So again, whenever two fractions have the same denominator and you're adding them together, you just keep the denominator the same, and we just add those numerators together. So now I'm going to have to add 4 plus 5. Well, I know that 4 plus 5 is equal to 9. And now I need to go ahead and change 9/6 to a mixed number. Now here is one thing that I'm going to show you slightly differently, because if you are a fan of number bonds, this might be an easier way to change it to a mixed number. So remember, mixed number is all about taking out the wholes. So the first thing you would do with a number bond is taking out as many wholes as you can. So our denominator is 6, that is not changing. So I'm going to start off by just doing one whole, 6/6. And I'm going to circle that and just write 1 over to the side to remind myself. So then in the second part of the number bond, I need to write what is left over after taking out 6/6. So again, my denominator is staying the same. I am not changing that. And I just need to figure out how many sixths are left after I start out with 9/6 and take out 6/6. Well, I know that 9 minus 6 is equal to 3, so that means that we have 3/6 left over. So again, I still found my mixed number, I just did it in the number bond style. So if the number bond works for you for doing that part, awesome. go ahead and do that. I will also be doing the regular mixed number that we have been doing right over here to the side. So the way that we have been doing the mixed number is by seeing how many times 6 goes into 9. Well, 6 goes into 9 one time. And again, my denominator stays the same. And then 1 6 is 6, and I either have to count up until I get to 9, which is our old numerator, or do 9 minus 6. Either way, we get 3/6. And we end up with the same answer that we did with the number bond style. It's just whatever is easiest for you. And again, we're not quite done with our actual answer yet because we still have that whole number 3 over there that we cannot forget about. So we're just going to add our whole numbers together. So we're going to add 3 plus our 1 whole either right there or right here if you did the number bond. Either way, 3 plus 1 is equal to 4. And then we just add on our 3/6 that's hanging out right over there. And again, guys, if you can do this in your head, that is awesome. Go ahead and do it. I just want you guys to solve these problems in whatever way is easiest for you. Let's keep on going. Moving on to part B, we have 1 3/4 plus 3 3/4. So I'm going to start off by adding these whole numbers together. 1 plus 3, well, I know that 1 plus 3 is equal to 4. And I'm just going to leave that whole number hanging out there for a second, and I'm going to focus on adding those two fractions together. So I have 3/4 plus 3/4. Again, when I'm adding fractions together, if they have the same denominator, then I am not going to mess with that denominator. I will keep it the same, and I just have to add those numerators together. So 3 plus 3, I know that that is equal to 6. And again, I'm not done because 6/4 is an improper fraction, which means that I have to change it to a mixed number. I'm just going to keep on going in the regular way that I do of converting from an improper fraction to a mixed number. But once again, guys, if you want to do the number bond, that is totally fine. However you need to solve it works. So I'm going to start off by figuring out how many times our denominator can go into our numerator. Well, I know that 4 can go into 6 one time. I don't change my denominator. And I know that 1 4 is 4. And I just need to count up 2 more in order to get to 6. So I have 1 2/6. Now my last step to figure out my entire answer is to add those whole numbers together. So I have 4 plus 1. I know that that equals 5. And then I write that fraction part and just tack it on to the end. So 4 2/4. Part C, we have 3 3/8 plus 2 6/8. So yet again, I'm going to start out by adding my whole numbers together. So 3 plus 2. Well, I know that 3 plus 2 is equal to 5. I'm going to leave that 5 hanging out over there for a second, and over here in this space, I'm going to go ahead and add those two fractions together. 3/8 plus 6/8. Again, if I am adding two fractions and they have the same denominator, that means that I am not going to mess with that denominator. I'm going to keep it the same and just add those numerators together. So 3 plus 6 is equal to 9. And again, I'm left with an improper fraction, so I have to change that improper fraction to a mixed number. Well, I know that 8 goes into 9 one time. I know that I'm not going to change my denominator. And I know that 1/8 is 8, and the difference between 9 and 8 is 1. So I am left with 1 1/8. Again, I'm not quite done yet. I need to take this whole number that I just left hanging off to the side and add it to my other whole number. So 5 plus 1. Well, I know that 5 plus 1 equals 6. And now I just have to add this little fraction to it as well. So 6 1/8. Number 4, we're just going to keep on doing the same thing. We're just going to add the whole numbers and the fractions together. So A, I have 1 3/5 plus 3 4/5. So I'm going to start off by adding those whole numbers together. So I have 1 plus 3, which is equal to 4. And then I'm going to add those fractions together. So 3/5 plus 4/5. Again, when I'm adding fractions, I know that if they have the same denominator, that means that I don't touch the denominator, I leave it alone. And I just add my numerators together. So 3 plus 4, that equals 7. Now I have 7/5, and that is an improper fraction, so I am going to change it to a mixed number. I'm going to do that by seeing how many times 5 goes into 7. Well, 5 goes into 7 one time, and my denominator stays the same. 1 5 is 5, and the difference between 7 and 5 is 2. So I am left with 1 2/5. And again, I don't have my exact answer yet. I need to add this whole number that's hanging off by itself, plus that whole number that I just found. So 4 plus 1, which equals 5. And then I just add my 2/5, my fraction, on to the end right there. That is a wonky looking 2, but you guys get the idea. Okay, part B, almost done. We have 2 6/8 plus 3 7/8. So I'm going to just start off by adding those whole numbers together. So 2 plus 3 equals 5. And I'm just going to leave my 5 to hang out there while I add my fractions together. So I have 6/8 plus 7/8. And again, if I'm adding fractions, I know that if the denominators are the same, I just leave those denominators alone and add my numerators. So I'm going to add 6 plus 7, which I know equals 13. And yet again, guys, I have an improper fraction that I need to change to a mixed number. So I need to think, how many times does 8 go into 13? Well, I know that 8 goes into 13 one time. And I know that I'm not changing my denominator. And so now I need to figure out my new numerator. Well, I know that 1/8 is 8. And so I have to figure out the difference between my old numerator, 13, and 8. So I can either count up from 8 to 13 or do 13 minus 8. Either way, I get 1 5/8. I'm not quite done yet because I need to take this whole number that's hanging out by itself and add it to the whole number that I just found. So 5 plus 1, I know that that equals 6. And then I just have to write my fraction that's hanging off to the side. So 5/8. And now our last one for this problem set, we have 3 8/12 plus 2 7/12. So again, I'm going to start off by adding my whole numbers together. So I have 3 plus 2, which I know equals 5. And that came out looking really weird, so I'm going to fix that. And now while my whole number just stays out over there, I'm going to go ahead and add my fractions together. So I'm going to do 8/12 plus 7/12. And again, I know that if I'm adding together two fractions and the denominator is the same, that means that I'm just going to keep the denominator the way it is and not change it. And now I'm just going to add my numerators together. So I have 8 plus 7, which I know is equal to, sorry guys, 8 plus 7, which I know is equal, sorry for the sudden pause, guys. I had a little bit of a coughing fit. Anyways, I know that 8 plus 7 is equal to 15. And now, again, I have an improper fraction that I need to change to a mixed number. So I have to see how many times does 12 go into 15? Well, I know that 12 goes into 15 one time, and I know that I am not changing my denominator. And now, in order to figure out my new numerator, I can either start at 12 and count up to 15, or do 15 minus 12. Either way, I end up with 3/12. And now for my very last step, before I can write my final answer, I have to add my whole number that's hanging out to the side plus that whole number that I just found. So 5 plus 1, which equals 6. And then I just have to write my fraction that is off to the side. So 6 3/12. And that is the entire lesson. So for your homework slides, you have slides 4 and 5. And yet again, I just want the answer. I don't care how you solve it. As long as you solve it, just make sure that whenever you have those improper fractions, you change it to a mixed number before writing your final answer. As always, if you guys have any questions, feel free to leave me private comments on the assignment and I will answer them when I can. I will see you guys later. Bye.